If you want your rolling stock to run a little bit better, there are several ways that you could accomplish this. And I'm going to tell you about one way that we could do that with this scale right here. It's a very inexpensive scale that we could check the weight on there to get all your rolling stock at the proper weight. I'm Tom Kovichak, and this is Tom's Trains and Things. This channel was created to help other modelers who are in need of guidance in pursuing their dream of building a model railroad. This video is a paid product placement. I've received this scale for free, and also this constant voltage and amperage power supply from Banggood. And you can see the links for these two products in the description of this video. We're going to take the recommendation from the NMRA, and I'll show you the chart right here, the RP-20.1 car weight. And we're going to go to HO scale. You can see the initial weight is 1 ounce, and for every inch of car length, we're going to add a ½ an ounce. So on most of my rolling stock, it's 5 3/4 inches long, which is going to be 3.875 ounce, which is about approximately 109 grams. And the caboose is 4.5 inches long, which is 3.25 ounce and 92.1 grams. So that is the optimal weight. What I'm going to show you is what the actual weight is of these pieces of rolling stock and how we would go about adding weight to them to get them up to the NMRA standards. Okay, I have my scale and I have my power supply here. And one thing that I didn't show you, everybody has a transformer, whether you've been working on DC, if you're still working on DC or DCC, you have a transformer, DC transformer. You can power this power supply here and get the voltages that you actually need. I have this hooked up to a Tech 2 2500 Locomotion 2500 power supply that you've seen me use before. Okay, on here, this is the regulated power supply. I'm going to turn this on. And you can see I have it set for 5 volts. It shows up 4.99 volts. Let me turn on the scale. And what I did with the scale, before you start on it, you're going to need to make an adjustment for the proper weight on here. Normally you would take like a ½ ounce or 100 gram weight and put it on there, something that you know the weight on, but I don't have anything like that. So what I did was I looked up the weight of my cell phone, which is 155 grams, and placed it on here and adjusted this to where it would come up to 155 grams. Now I also did it with another component that I had, and it came out pretty close, so I'm using this cell phone as my reference. So I'm going to start off with this boxcar right here and place it down on the scale. Okay, we're 85 grams, and what I figured out for the 5 3/4 inch rolling stock is I need 109.8, so roughly 110 grams. So really we're only about 25 grams off on that one there. Let's put this log car on here, and this one's a little bit heavier. This one's 99 grams, so we're only 11 grams off on that. If I needed to, I would cut into one of these logs in the center and add a lead weight in it. I have this coal car here. I have a lot of coal cars with different road names on it, and these are 83 grams. So it's not too far. We got to get up to 110 grams, approximately 110 grams. This caboose right here, now our optimal weight would be 92.1 grams or 92 grams. So what we're sitting at right now is 71. So we're only 20 grams away. So what you can do is take this apart, get a piece of metal and put it inside there, or if you fish, get some sinkers, melt them down, weigh them, and then stick them down in the bottom, glue them down into the bottom like that. It's as easy as that. Now, those of you that are modeling different scales, your figures are going to be a little bit different. As you can see, depending on what scale you're in, just check the chart and see what it is, calculate what your optimum weight would be, and then work from there. To convert your grams to ounces, there are apps that you could use on your cell phone, and also just go and Google it, like here. Gram to ounces conversion. You can see I have the figures up here already. 3.875 ounces is 109.85. So that's where I got the 110 grams. Let's take a look at the components now and see how we hook them up. Like I told you before, if you have an old transformer, say like this old Tech 2, now this one has an extra set of terminals on there for straight DC, but you could use the variable DC on there and adjust your throttle and hook that up to this power supply here. All you have to do is determine which is your positive and negative. You have a positive terminal here, you have a negative terminal here. Just make sure you match that on your transformer. You take your wires from the output on there, and I have it on a plug. I put it onto a plug here and just plugged it right into the scale. Now this is the easy part here. This comes fully assembled. Now the fun part of this is this scale right here. This is a kit and has to be assembled. It has a circuit board on there where you have components you have to solder on, and then you have some connectors on the display and on this board right here. Like I said earlier in the video, the links to these two components right here is in the description of this video. You can purchase them from Banggood. The operation and setup of this power supply is pretty straightforward. You have your buttons over here for programming it, and you have your on-off switch right here, and you have your knob right here where you could adjust up and down, and it also has a function where you could push the button. Now if you want to set anything on here, you can see you have many different options on here. Let's go down a little bit further and I'll just show you on here. Now here's the LED. This, okay, you can see the brightest is 5 and it goes down to 0. The default on here was 4, so we're just going to keep it like that. When you're finished, you set it. Now on this one right here, M pre, you have 10 presets that you could set this thing up with. And it's just like programming anything on your throttles for your model railroad. It's very simple. You have the up and down, you have the set, and once you're finished, you hit the set, and there you go. Very simple to program, and it's already assembled. You don't have to do anything but attach your wires onto it. You attach your input over here, 0 to 60 volt DC, and you attach your output here, 0 to 50 volts. You have a nice instructions. It comes in Chinese and English. It's easy to follow. Now the scale, that's a kit. You're going to have to assemble it, and you're going to have to solder everything onto the circuit board. But it's pretty easy. And let me show you some of the highlights that I've gone through in assembling and soldering it. After playing around with this for about 10 minutes, I figured out just about the location for all the components on here. The first time I looked on the other side, everything was screen printed on there backwards. Before I did anything on here, I wanted to get a dry fit of the box to see how it is assembled. You can assemble this thing backwards because the side panels are identical. So you could turn things around and get everything out of shape. You have the 4 push buttons in the front, and then you have the 10-pin connector right there. You want to make sure that your board would fit in there. On the side of the board, you have a power connector and a little toggle switch on there, which fits on the side. So you have to make sure that this is on here on this side, and then your holes for your power connector and a little toggle switch. There are some issues that I found with this when I was assembling it and soldering it, and I'll go over those issues with you right now. The operation of this scale is pretty straightforward. You have the 4 buttons on there for the reset, up and down, and set for tare weight. You have your LCD display on there, you have your load cell, you have your plastic case, which is pretty easy to assemble. Now there are some issues with this. On the back of here, the screen printing of the pins on here is backwards. The directions for this unit is only in Chinese. It's mostly data sheets. It really doesn't show you how to assemble it. I had to do a lot of optional things on here because some of the parts that they supplied with it didn't fit. And let me start on the bottom to mount the circuit board. On the circuit board you can see I have a screw here, and there's a hole here. Well, they supply you with these, I guess they're nylon standoffs. The only thing is they're too big. They don't fit in the hole for the box, and they don't fit in the hole for the circuit board. If you're experienced, you'll be able to find where the problem points are. This is the biggest problem point right here. If you put it in where you think most likely it would be, because on the diagram, and let me pull up the diagram right here, 1 and 2, number 36. You see one side is ground, and number 2 is your voltage in. So if you put a switch on that to turn it on, all you're doing is going straight to ground. You're short-circuiting it. But anyway, you can see right here, this is where the 2-pin JST plug should go. But I had to remove the toggle switch right here and solder the JST connector in here for the external power switch. And you can see this right here. This isn't in this project, but it shows something here. So this must go to several different projects, but everything else is on here. This is absent, and this is absent. And then there's a plug here, but you don't have no idea what it goes to. You mount the LCD display. On one side it fits on the header. The pins fit right in the header, and that holds that side in. But on the other opposite side, you have nothing to hold it in unless you use the standoffs that they supply, these little long nuts. The only problem is they're not long enough, and you have to squeeze it down and get the LCD display off center. The other problem with that is they give you screws for that with a built-in washer. So in effect, it makes the head of the screw a little bit bigger. When you mount it here on the circuit board, it doesn't allow you to put the front plate on. So I put these screws, 6/32 screws in there with the nut, and I spaced it appropriately. I double nutted this side here to hold it in to the height that it's supposed to be. Now the only problem with that is you put a screw through the side here and put a nut here. The nut will not go all the way in to match up with the screw, so you can't put any fasteners in the front plate except for on the bottom. So this just sits here loose like that. It's a very bad design. They could have moved it over either way a little bit to accommodate it. What I think is they made this circuit board and the LCD display for another kit also, and this was a second thought here, especially with this plug and where the toggle switch goes. I think these 2 pins right there was originally for external power to something. And I had to go onto YouTube for an Arduino project to find out where the wires go on here. Now there is a diagram in the set of instructions, but it's in Chinese also. It tells you what pins to go on, but it doesn't tell you what colors unless you are able to translate the Chinese description on it. So I found out that it is red, black, white, and green in that order, and that's on the E plus, E minus, A plus, A minus. You don't use the B plus and B minus on there. One good thing about it, if you need a larger space for your scale, you could get a larger piece of acrylic. It will adjust for the tear weight on there. You just have to use your reference to adjust your reference point on there, like I showed you how on the beginning of this. This is a really great constant voltage, constant amperage power supply for any projects on your model railroad. This is a good little scale. Hopefully the manufacturer will put the correct parts in here and correct the discrepancies in the circuit board. So until the next time, we'll see you.